Welcome. Today, we'll calmly examine the most critical yet frequently overlooked phase of research, problem formulation. As Einstein wisely observed, formulating the exact problem is often much more essential than its eventual solution.
Here's our syllabus. We'll thoughtfully explore Type 3 errors, cognitive causes, common traps, and practical frameworks.
Consider a manager eager to drive a massive change initiative at Harley-Davidson in the late 90s.
Consultant Hajime Oba refused to proceed until the manager answered one absolutely foundational question.
This beautifully illustrates the Type 3 error. That's when you perfectly solve the wrong problem. Why does this happen? Well, our brains naturally favor rapid pattern matching over slow, conscious, logical reasoning. In fields like data science, leaders often rely on gut intuition rather than careful problem formulation. This disconnect creates systemic failures, misaligned teams, and totally unrealistic expectations, often fueled by hype. Let's slowly examine a taxonomy of cognitive traps that practically guarantee you'll make a Type 3 error. Here are the 4 most common pitfalls researchers and managers face when rushing blindly forward. First, the streetlight effect. This is formulating a problem simply because the data is easily accessible. Second, being solution-driven. That's when we stubbornly push a preferred method to solve a pseudo-problem. Third, gap spotting. Just because past research ignored a specific gap doesn't mean it actually matters. Finally, derivative answers. Re-evaluating known theories in slightly new settings rarely advances our fundamental knowledge. To avoid these traps, let's explore a framework for structured, logical, and effective problem formulation. A rigorous, highly effective problem statement strictly requires these 5 essential structural elements. Remember, even subjective variables, like customer trust, require a quantifiable direction to accurately measure progress. Apply the Goldilocks principle to your scope. Carefully avoid the extremes of being too broad or too narrow. In practice, use a scope-down tree to strategically isolate a specific problem manifestation for rapid feedback. Then, apply Deming's iterative cycle to carefully test your hypotheses in a controlled, scientific manner. Ultimately, success demands connecting diverse, interdisciplinary perspectives to clearly illuminate the broader, archetypal problem. Before committing resources to your next project, simply pause and ask, what problem are we truly solving?